I'm going to explain the behavior predicted by Raoult's Law, which essentially occurs when we have an ideal gas and vapor phase mixture in equilibrium with the liquid mixture that's an ideal liquid. And so essentially it says that the partial pressure of component 1 is proportional to the mole fraction in the liquid phase times the saturation pressure. So X is the mole fraction in the liquid phase, and Y is the mole fraction in the gas phase or the vapor phase. So if we look at a plot of pressure versus mole fraction, we can see that pressure versus x1 is a straight line. This is the green line. Similarly, pressure versus x2, partial pressure that is, of component 2 versus x2 is a straight line. Partial pressure is x2 times P2 sat. And of course, x2 was 1 minus x1 times P2 sat. So we have two straight lines. The total pressure then is the pressure of 1 plus the pressure 2. It's the sum of these two straight lines, x1 P1 sat plus x2 P2 sat. The concentration of mole fraction of Y now in equilibrium, once we have this pressure versus X line, the actual mole fraction of the vapor phase, so the mole fraction of component 1 is x1 P1 sat just divided by the total pressure. So this is value of x1. The corresponding value of y1 that's in equilibrium is over here. So this line, this is the y1 value in equilibrium with this x1 value. It has to be at constant pressure. And of course the whole plot is at constant temperature. The corresponding temperature versus x1 and y1 diagram. So here's an approximate representation. And the first thing to notice that where this slopes is positive for p versus x1, these t versus x and y have slope negative slopes. y1 is greater than x1 in this diagram, just like y1 is greater than x1 in this diagram. Component 1 has a higher saturation pressure, therefore it has a lower saturation temperature. Whereas in the pressure diagram, this is a straight line for Raoult's Law. Neither one of these are straight lines. So it's important to understand our normal convention is to pick component 1 in these plots as the component with a higher saturation pressure. This is P1 sat here, this is P2 sat. And that means component 1 then has the lower saturation temperature at a given pressure. And then for an ideal solution, y1 is greater than x1 in both of the diagrams.